All right, let's talk about something pretty cool. Have you ever thought about having your own truly private AI? I mean, a seriously powerful one, where you don't have to send your data off to some giant tech company. One where you are completely in control? Well, that dream, it's way closer than you might think. But is the performance we're seeing actually real, or is it all just hype? Let's dive in and find out. So, right now, we're all pretty much living in the world of cloud AI, right? It's super convenient, no doubt. But it's got its downsides, like high unpredictable costs, and the big one, you're basically just handing over all your sensitive data. But now there's this alternative popping up called sovereign AI. The idea is simple. You buy the hardware one time, and that's it. You get total control and complete privacy. It's really that classic showdown, convenience versus control. Okay, so what is sovereign AI in plain English? Well, it's pretty straightforward. It just means you're hosting these huge, large language models on your own computers, on-premise, in your own building, under your full control. No third-party cloud providers, no sending data anywhere. It's just you, your hardware, and your AI. That's it. Total control. And that brings us to this really fascinating experiment I came across, a research paper that tried to answer a pretty bold question. Can an individual or a small company actually build their own private AI server that can go toe-to-toe with the billion-dollar giants? You know, it's like building an AI David to take on the Goliaths of the industry. Now, you might be thinking, this requires some kind of crazy, exotic, super expensive hardware, right? But just look at the recipe they used. We're talking a consumer-grade NVIDIA GPU, a pretty basic Intel Core i3 CPU, and only 16 gigs of RAM. I mean, this is stuff you could literally go out and buy from a store today. The real magic here, the secret sauce, is the combination of a powerful open-source model and a really efficient framework to run it on. So the big question is, how on earth do you cram a 30 billion parameter model onto a regular old PC? Well, the key is a trick called quantization. The best way to think about it is, it's like compressing a massive file, zipping it up. You're essentially shrinking the AI model so it can fit into the computer's memory, but you're trying to do it without losing much of the quality. Honestly, this whole experiment wouldn't even be possible without it. Okay, so our Underdog server is built. We've got off-the-shelf parts, some really clever software. The stage is officially set. But now for the million-dollar question. Can this homebrewed AI actually compete with the giants? Can it hang with the billion-dollar models? Let's take a look at the results. All right, first up, let's look at the tests for pure intelligence. Can this local model actually think? Can it reason? Can it answer tough questions just as well as its massive cloud-based competitors? This is really where the rubber meets the road. And honestly, this first result is pretty shocking. What you're looking at here is a benchmark that's packed with really tough math and reasoning problems. And our little local server, that's the one in orange, it's right there in the mix. It's not just keeping up, it's scoring competitively with giants like Gemini and Claude. In some cases, it's even beating them. This is a huge win for the little guy. And get this, it's not just good at math. On another benchmark that tests a huge range of general knowledge, our little server that could scores an incredible 83%. That puts it firmly in the high-performance band, just a few points shy of the absolute best models out there. So the big takeaway here is that when it comes to raw intelligence, a private AI is no longer a compromise. The quality is definitely there. Okay, so we've established one thing. It's really, really smart. That's a huge hurdle cleared. But an AI server isn't all that useful if only one person can use it at a time, right? The real test for any system is how it performs under pressure. So what happens when you add a second user? Or a third? Let's see. And, well, this is where we see the first major crack in the armor. What this chart shows is basically how much work the server is getting done. And look what happens. The efficiency just collapses. It drops by 75% with just a second user. The system basically can't handle it. It just starts lining people up in a queue. So yeah, it's smart, but it's absolutely terrible at multitasking. This is a big, big dose of reality. So we have a model that's brilliant but can't handle a crowd. But wait, because the story doesn't end there. A second, and I think crucial, piece of research comes along and asks an even bigger question. Are those amazing intelligence scores we just saw even real? What if the problem isn't the AI, but the test itself? This all comes down to a classic idea in economics and statistics called Goodhart's law. The gist of it is this. When a measure becomes a target, it ceases to be a good measure. Think about it.
Once everyone starts chasing a specific score on a test, they'll find ways to game the test, often without actually learning the underlying skills. The score itself becomes the goal, not real knowledge. And this might be exactly what's happening with AI benchmarks.
In the AI world, this problem has a very specific name. It's called benchmark leakage. And the best way to understand it is to imagine you're about to take a huge final exam. But then, your professor accidentally includes the entire exam with all the answers in your study packet. That's pretty much what benchmark leakage is for an AI. If the test questions get mixed into the giant sea of data the AI learns from, then it's not really learning how to reason, it's just memorizing the answers. So, the obvious question is, how big of a deal is this really? Are we talking about a small boost, maybe a few extra percentage points? Or is this something that could completely throw off the results? Well, to find out, researchers decided to run an experiment where they intentionally leaked the test data to a few smaller AI models. And the results are, well, they're absolutely staggering. Just look at this table. Take a look at the jump for one of these models. Its score goes from a kind of mediocre 26% all the way up to an incredible 87%. Another one skyrockets from 43% to over 96%. This isn't just a little boost. This is a totally game-changing distortion. The AIs end up looking like super geniuses, but really, they've just been given the answer key. But here's the real kicker. The research showed that if you let it cheat this way, a tiny 1.3 billion parameter model could actually be made to score higher than a massive 65 billion parameter model that took the test fairly. I mean, that completely turns the leaderboards on their head and really makes you wonder if we can trust any of these scores. So let's step back and put these two pieces of the puzzle together. On one hand, you have this incredible, exciting promise of powerful AI that you can run yourself on your own hardware. But on the other hand, we have this really deep problem with how we even measure how good these AIs are. So what's the real score here? So what are the main takeaways here? Let's break it down. Number one, yes, powerful private AI running on consumer-grade hardware is absolutely becoming a reality. That's not hype. But number two, getting that AI to work for more than just one or two people at the same time, that's still a massive hurdle. And finally, number three, we have to be really, really critical of AI benchmark scores. There's a very real chance they're inflated. A model's real performance is so much more than just a single number on a leaderboard. So how do we fix this broken test? Well, the researchers suggest a pretty clear path forward. For the AI developers, they need to be way more careful about cleaning test data out of their training sets and just be open about it. And for the folks who create the benchmarks, they need to mix things up, use changing questions, and start requiring what they call contamination reports to prove an AI hasn't cheated. And all of this leaves us with a pretty big lingering question. The dream of having your own private, powerful AI is clearly within reach. But in a world where it's so easy to game the tests, a world of benchmark leakage and performance hacking, as these AI systems get more and more integrated into our lives, how are we ever going to know what's real? How will we separate genuine intelligence from just a cleverly engineered illusion?